One way to represent that is to report the range of a measurement. So consider we are weighing our sample 5 times. So I got these 5 different measurements. So when I put my sample onto the analytical balance, it's very sensitive balance, right? If you guys used that before, the analytical balance, it can measure up to 0.0001 gram. So when I repeat the measurement 5 times, I get 5 different results. Then we can report the range of the measurement. So we take the highest measurement amount here, which will be 2.0004, and the lowest, take the difference, that will be 0.0007. Then we could report the range. So take the medium on that range. So that's a medium in that range. It's not mean. So the medium will be 2.00040, and then we say plus minus 0.0004. So that covers the whole range of my measurement. And that's one way to report it. The other way to report it is report the average absolute deviation of the measurement. I can calculate the average, which will be 2.0000, with 4 zeros, and then we calculate the average absolute deviation. The average absolute deviation is shown as this equation. So this delta W, that's the deviation of each measurement. So for example, first one will be 0.0001. And the second one is the same as average, so it's just 0. And third one will be 0.0003, and third one will be 0.0002. So it's just taking the absolute difference between the measurement and the average, and sum all those 5 together and divided by n minus 1. So n equal to 5 here, minus 1 is 4. The absolute deviation will be 0.0003 gram. And we can report this as a 2.000 plus minus, this is a typo here. It should be 0.0003 gram. More commonly, we would assume the measurement will fit into the Gaussian distribution, and that's, or we can call that normal distribution. In the Gaussian or normal distribution, we have this equation that's a P, that's a probability, mu, that's a mean value, and X, that's each individual measurement value. And that should fit into this distribution. And sigma here is the standard deviation of the whole distribution. So if we look at the confidence level at 1 sigma, okay, so plus minus 1 sigma, the confidence level will be roughly 68%. What does that mean? The 68%. So that means the area covered by the curve, if we just look at the plus minus 1 sigma here, the area will cover 68% of the whole area that's under the curve. So 68% of the incident will happen within that plus minus 1 sigma. In scientific measurement, we use 95%. So roughly 2 sigmas. So roughly here, that's what we want to cover. As we mentioned before, if you want to have a complete normal distribution, you want to have a standard deviation, you need a lot of measurement, at least 100 times measurement. And that's not practical in the physical chemistry measurement. So what we do is to use the estimated standard deviation, or that can be called the standard error, to represent the standard deviation of the whole distribution. So the SM is the standard error that equal to standard deviation divided by the square root of number of events. After we figure out the standard error, then we can look up the T table and use degree of freedom to find the T value. And we can calculate a lambda, which is T times the standard error. Then we use that as the range to report. So we can report the mean and the plus minus this lambda we can calculate it, and also report the confidence level with a number of events. I think probably some of you guys used the T table before. That's a typical T table. Then we can see as one, we have limited number of measurement. So the degrees of freedom is small in this region. So if we have a 5 measurement, as we showed before, the degree of freedom will be 4. Then if we look at the 95% confidence level, it's 2.78. That's significantly larger than the standard deviation. However, when we approach to more than 100 times measurement, so still at the 95% confidence level, we can see the T value now is very close to the sigma value, right? 1.98. The sigma we have for 95% is 1.96. So when you have a serial number of measurements, just as before, you can calculate the mean, right? And how do you calculate the standard error? You can use the Excel. You can use this equation here, or you can directly use Excel. If you use Excel, there'll be standard dev dot S. So that will calculate the standard error from your sample. So there is a dot S after standard dev, the function standard dev. That will calculate the standard error of your sample. Let's go back to this example. I have still this 5 measurement. Right now, I want to report my measurement with this method. So I'm going to report the mean plus minus lambda. I want you guys to try to calculate the lambda value and show the similar reporting here. Calculate the SM will give you this value, and then look for 95% degree equal to 4, and you get 2.78. You calculate it and run it up either 8 or 9 and report that the confidence level at 95% and n equal to 5.